Hello friend and welcome to today's video. So today we're going to learn the control chart for variables that are using for to control the measurable quality characteristics. Okay, so we use the control chart for the process mean, that is X bar chart, well known for controlling the mean of the quality characteristics for process means. Okay, with the help of X bar chart we monitor the variation in the mean of the samples that we have been drawn from time to time from the process. Okay, so let's start with one example. Okay, for example, we consider a problem related to manufacturing process for maintaining the quality of bottling procedure. Okay, so for example, a fruit juice manufacturing company uses automatic meshing to fill 500 ml for say 500 ml juice bottles. Okay, so they hired a quality control inspector at their company, and he collect 25 samples. This is 25 samples. Till 25 we are getting 25 samples of 4 observations: observation 1, observation 2, observation 3, and observation 4. Okay, and we took these observations for different times and measure the volume of each bottle filled. This is the measurements in ml. Okay, that's have written over here. So let's start with this. The quality control inspector of the company needs to develop a X chart to check whether the process of bottling is under control or out of control. Okay, when process variability is known. So in this case we know the process variability. Okay, so therefore we have to construct the control chart for the mean using the data given in this table. Okay, and for example they already give a standard deviation of bottle operation, that is 2.5 ml. Okay, so write this over here. I have already put it that standard deviation, it is at say 2.5 ml. Okay, and here we know the number of observations. There is only 4 observations, and k is representing the samples, so we have 25 samples. This is okay, 25 sample. Now we have to calculate the X bar. Let's start. So just write over sample mean. Okay, what would be a sample mean? I hope you already know this formula. Okay, let's drag it till 25. Yeah, it's done. And now we have to take this sample, average of these values. Done. So we have the X bar value 499, total number of sample 25, total number of observation 4, and standard deviation is 2.5. Okay, now we have to try for to get the value of central line and UCL, that is upper control line, and LCL, that is the lower control line. Okay, just write over there central line. Central line, UCL and CL. This is for control limits, right? Okay, I just do one thing, some basic Excel tactics for better understanding or for better view. Just omit these values, put a table. Now, this is for our ISO thing and for better understanding. Okay, let's start now. Now we have to get the value of center line. What your center line? Center line, it will be your X bar. Okay, that is the F28, cell number F28. Okay, just write over here. So to not get this value change, so we freeze this cell. As usual, just drag it to 25 samples. Yeah, okay, we got our center line. Now we have to put formula for upper control line. Okay, for upper control line we know the formula, that is x bar plus 3 into standard deviation divided by root of n. N is here 4, this one. Okay, so let's type over here. See it properly how I draw that, write the function. So number 28, that is x bar to the x bar plus 3 multiply with deviation multiply sigma, again freeze this. Divided by square root of which one, that sample, it is this one. Let's freeze it because we have to drag this. Okay, now I get that. UCL, upper control line. Now we'll calculate the LCL. So it's the same, just in LCL we have to put minus instead of plus here, just change this to minus. That's all. Okay, that's our data is now prepared. Okay, now what we have to do, we have to for visualization. So main thing has already done. Okay, we from that observations and the samples we draw the sample means, and depending on the sample means we draw the control limit, that is central line, upper control line and lower control line. Now for visualization purpose or for better understanding, let's draw a chart for this. Okay, so for this we have to select this, selected this data, insert. What we'll put a line chart for this. Oh, sorry. Okay, we have to only take this data sample means to use LLCL. Yeah. Here we have the data. Okay, so now you can see that all the values are within the control lines. So what we can interpret from this letter, from this experiment, or from this chart, so that all the points are within the control limits. See, all the points are within the control limits, the upper control line and lower control line. So we can infer that the process is under statistical control. Okay, so that's all. So you can make the graphic more interactive, like say put it around, we put it and drop. We don't need these grid lines, so just, yeah, we need for better understanding we need some titles. So this is the sample number. That is this. This is juice volume in ml. ml. Now I'm going to change some line. This is for upper control line. Yeah, I hope you get our understanding after modifying this chart. So this is all the sample numbers. This is the juice volume in ml. So this line is upper line is representing the UCL, that upper control limit, and this dotted line are representing the LCL, that is lower control limit, and this red color line is representing the central line or the mean value. Okay, and this all here also. Hmm. See, uh, here we draw that this line representing the sample meals from these data, from these observations. Okay, so what we see that all the observation are within this control limit that we have got, that is the upper control limit and within the lower control limit. So there is no need to change any mechanical process of the machine. So what we can see that all is working very fine in this statistical control example. Okay, so that's all for today's. So if you need any help or if you have any questions, just put a comment or you can directly write to me. I will be happy to help you. Okay, till then, stay safe and stay healthy. Goodbye. Thank you.